Welcome to Fleet News Group podcast. I'm Caroline Fall, and today my guest is Bart Moonen, Executive General Manager at Infinitev, an ASX-listed, Amotiv-backed hybrid and EV battery recycler and leading the circular economy for batteries in Australia and New Zealand. Welcome, Bart.
Thanks, Caroline. Pleasure to be here.
Now, we've spoken previously on this podcast with your colleague, the fabulous Dixon Liao, about how Infinitev established itself with technology to repair and recycle vehicle batteries and save all the chemicals and materials from landfill. And we'll go back over some of that ground later. But first, the big news is that your Melbourne-based Infinitev has recently announced a collaboration with the biggest battery system maker for buses outside of China, and that is the France-based group Forsee Power. So do you want to tell us a bit more about Forsee and what that means for Infinitev here in Australia and New Zealand?
Yeah, absolutely. So we're very excited to be working with Forsee. As you mentioned, they're the number one manufacturer of smart battery systems for buses outside of China. They work with other vehicles as well. They do work on off-highway vehicles, so stuff that you find in mining sites, trucks, trams, and that sort of thing. And for us, what's really excited to be working with them is that they've got some really nice advanced systems that also require maintenance and after-sales service. So as you can imagine, if you're running a bus, you want that bus to be on the road as much as possible. And being a French company, they need people on the ground to deliver that service if a bus battery system does need repair. And that's where we come in. So we work with Forsee Power's customers to make sure that if there is an issue with the battery, they get the bus back on the road as quickly as possible.
Like I promised, let's just go back to basics and talk about circular economy generally, which is still sort of inchoate in that it's not widely understood or in place. So the way I like to explain it is that it's a system that respects natural commodities, that they're finite rather than infinite. And so instead of taking natural resources from the earth for every little thing that's made, we want to reduce, reuse, repair, remanufacture, and I guess finally recycle products and components. So importantly, products need to be designed for all that. So I wonder if you can tell us about how and if vehicle batteries are being designed for circular economy principles.
Well, sadly, Caroline, the truth is that many of them aren't yet. So what we do see is that many of them have been designed in that traditional linear fashion, right? So we take materials from the ground, we make stuff with them, and then when it fails or when we're done with them, we chuck them out, goes to landfill, and then if we want to use more batteries, we've got to take more materials, make more things, and then use them again. So it's that linear system that keeps repeating itself. And as you mentioned, that takes a toll, right? A linear system is not wrong, but if you're in a position where the materials that you take are finite and the waste that you're generating is toxic, then it's not okay. And that's where that circular economy comes in. So some of the early generation battery systems that we see that not always designed with repairability and serviceability in mind, but we do see that changing. And a lot of that comes down to the maturity of the battery manufacturer, the maturity of the vehicle manufacturer to say it is wasteful to not extend the life of these batteries. Because when a battery fails, it's not the entire battery that fails, it's usually a component of the battery that fails. And you know, if you get a flat tire on your bike, you don't throw away the bike, you fix the tube and you keep pedaling along, right? But with batteries, we have that tendency of just chucking it out entirely. And that's really the mindset that we're trying to change. And our services are geared towards that repair. And if we can't repair it so it can go back into a bus or a truck, then we look at ways to repurpose it for energy storage, for other buildings and whatever you might have. So it is improving. We do see that with the next generations, we get more modular designs, more homogeneous designs, and they're deliberately built and designed now so that if a particular module fails in the battery, we can replace that, and then the battery goes back into the vehicle.
Oh, it's a little bit sad to hear. I wonder if you've got like any ballpark on what proportion, are repairable. As you say, it's increasing.
Yeah, so it's hard to put a number to it in the sense that it's a very rapidly evolving space. So it's more of a general trend that we can see. I guess the second thing I could say about that is there's different types of failure that can happen. Sometimes it's a failure of the battery cells or the modules, so the bits that hold the energy, but sometimes it's a failure of the connectors of the electronics that are used to control the battery and that integrate with the rest of the vehicle. Now, repairing or replacing a power relay assembly or a battery management system module is a lot easier, and that can be done typically. It's really the repairability of the cell structure that is the thing that we see becoming more and more serviceable with subsequent generations of battery packs. But it's hard to put a finite number to it, Caroline.
Okay, cool. Yeah, I was just thinking like the hookup with Forsee, and it just made me think that I guess bus fleets and heavy vehicle fleets are the ideal space for you to focus on, rather than car fleets where the first battery will likely outlive the fleet's use of the vehicle, in that it will be remarketed. Not sure if I said that right, remarketed. Anyway, and probably into the consumer second-hand market. So with buses and trucks where they keep their vehicles for longer than the life of the original battery, you can help those fleets reuse their vehicle batteries, their depots for vehicle charging. Can you talk about that?
Yes, so I guess to your first point, bus and truck and even commercial passenger vehicles, they do use batteries more, they use the vehicle more than I guess you and I do, right? So most of our cars, they just sit idle for 90% of the time. And so when you use something more, it's going to have wear and tear, right? It happens to the tires, happens to the wipers, happens to everything, including the battery. Now, obviously, batteries don't come to us when everything's good. They come to us when something isn't good, and they need to be repaired. And so bus, where they use the bus a lot, the batteries gets more exercise, so the odds of something going wrong increase. And for us, therefore, the odds of us going out and fixing that battery increase as well. Plus the fact that I guess the chassis and all that has a long life. So you might go through more than one battery system on the life of a bus. But I guess coming back to the other element there is that just because it's no longer good enough to power the bus, which is a very intensive application, right? It's the battery has to work really hard. You've got several tons that you got to put into motion quickly. When you brake, it absorbs all that energy very quickly. So it's a very dynamic use of that battery, which puts a lot more stress on it. And so at some point, there will be parts of the battery system that no longer can meet those dynamic demands of what a bus needs to be powered. But that doesn't mean that the battery is useless or dead, right? You can put it in a second life, a different application, such as energy storage, where it's a much gentler use of that battery, right? So if you're putting take a battery out of a bus, turn it into a battery energy storage system that sits at your depot to help power the facility, to help power the charger, and to take the trickle energy that comes from the solar that comes in. It's a bit like putting that battery into a 5-star hotel compared to the workhorse that it is in the bus. And when we put it in that second life, we repurpose it there, we can give it another 5 or 10 years of useful life. And I mean, this is also just a beautiful illustrative view of that circular economy, right? It goes from powering the vehicle to powering the depot. And then we go to recycling to recover the materials and build new batteries. But we're really stretching the use and the life of those batteries over many, many more years. Yeah, and it's good for the environment or not. Turns out it's also good for the bottom line. So we all win.
Oh, just a technical question. I'm not sure what the answer is, but I was just wondering how much material can be recovered from a a battery. So I think I once heard it was over 90%, like even 98%.
Yeah, so it'll vary a bit with the battery chemistry. So that has a lot to do with it. And then a battery system is more than just cells, I suppose, right? There's other stuff. There's casings, there's lots of wiring. There's quite a high amount of copper in these batteries. So all of that stuff can be recycled, right? Those processes exist. That's nothing new. But the exact percentage will vary from one battery to the next. But our aim is to have zero waste, right? And so with the right level of design thinking going into building batteries and making sure that materials can be recovered and first repaired, but once they reach that end of life that they can be recovered, then we feed that into existing recycling processes for scrap metal, for certainly the battery chemistry. So they get produced to a thing called a black mass or a mixed metal dust, and that then gets processed so they can then build more cathodes, which typically happens overseas. So there is quite a high percentage that can be recovered. Different processes have different yield rates, a lot of investment, a lot of research going on in that space as well. As you can imagine, the world is thinking about, well, how do we deal with battery waste as a specific subset of maybe the e-waste that we're all aware of. And so there's a lot of investment going on in that space as well. And the yields keep increasing with every year.
And you're here to help. Like you mentioned, battery chemistry, and so battery technology is rapidly evolving, and you've got smaller and cheaper systems and different chemistries. And since they have a life of several years in a vehicle, I imagine you at Infinitev need to be working with both legacy battery technology and then always be keeping abreast of like future compositions. And is that so? And is that something that you actually need to actively manage? Or do you do that?
Yeah, look, we certainly monitor it very closely. I'll be honest, it's a hard to track target, right? It's developing so quickly, and a lot of the development is either in the architecture of the battery, so how to actually build the battery, or in just the structural design of the battery. You get the skateboard design, which is very different from some other battery designs, and then the chemistries, right? So you've got we might have started with nickel-based batteries. Now we've got lithium-based batteries. There's a lot of variety within those. You get sodium batteries, all kinds of stuff happening. So we try and monitor and track it as closely as we can. But I guess to your point, we're really working on the batteries that need a bit of TLC to be revived, right? So they have been in the vehicle for a while. So in some ways, that gives us a bit of a lead indicator of what's actually in the market at a certain level and volume, so that by the time that there is an event where it needs a repair or a repurpose, that we've had enough time to, I guess, educate ourselves in enough detail to be able to work on that battery. And at the end of the day, they're batteries, right? Energy goes in, they're stored, and it goes out. So those principles are the same. There's a lot of nuance between different battery packs and architectures and chemistries, but the basics are the same. And the more batteries that we work on, I guess the easier it is for us to figure out exactly how does this particular battery work.
So all of this happens in your fabulous lab in Victoria, which I've been invited to visit but never actually got there. Do you want to tell us a bit about the facility and the current day-to-day operations and processes you deal with?
Yeah, absolutely, and certainly hope that we can welcome you here in person one day. So I guess there's two sides of our business that we operate here. There's a hybrid battery business. So we've been building hybrid batteries that are used in Toyota Prius, Camrys. A lot of rideshare vehicles use those. So we've been rebuilding those for quite some time, coming on to 10 years now. So they're a different type of battery. They're like an open architecture. It's a relatively easy to work with, but they're still high voltage batteries and well-designed systems. A bit more of a mature market. And then the EV battery repair is where a lot of investment, a lot of our effort goes into, but it's also very different, right? It's like an order of magnitude different from the nickel metal hydride batteries that you find in your hybrid vehicles. And so what happens when a battery comes to us is we first perform what we call a safety check. So it's a visual inspection and some other tests that we run to make sure that, well, is it safe to work on this battery? Right? Can we actually work on it safely before it then goes into our facility? All the batteries that come in, they have to be cleaned. We've got to remove any contaminants and pollution. When we do work on them, we put them into our clean room environment. So when we open it up, that nothing can get in there, right? So nothing can contaminate it. One of the biggest, opening up a battery is not that difficult. I wouldn't recommend that your listeners go and do it, right? You need certainly need decent training to do that. But part of the challenge is how do you put it back together again without having pollution of potentially conductive materials in there, right? And so you need to have a clean room environment. And we often talk about it's a bit like going to a hospital in a way, right? So everything is sterilized before it goes into the operating theater. Well, the clean room is our operating theater. It's got positive pressure. So when you open the doors, all the dust doesn't go in, it gets pushed out. The thing gets sterilized every so often, and all the tools that go in, everything gets wiped down and sterilized, and specific PPE has to be used, all that sort of stuff. But what it does do, it allows us to open up batteries, do the work that we need to do, and then put them back together again without the risk of any pollutants, right? So similar with an hospital, we're not leaving any tools in there. Everything gets taken out and then it goes through. And then one of the other things that we have at our facility is a fully automated test chamber. So to test that we've done the repair well, we have to put it through its paces and pretend like it's in a vehicle. So we stress it and we cycle it. And if anything were to go wrong with the battery, it's at that point, right? Because that's when you start really putting some energy through it. And so we've developed a system where if something were to go wrong, it's fully automated, people are separated from it, and we can contain any propagation that might happen. It's got, salt water baths, it's got extraction fans, all kinds of fancy engineering stuff. But it's to ensure that we've got the ability to test that the batteries are of the highest standard and meet the OE specification, but also it's safe for us to do the work. So yeah, there's quite a lot of stuff. You should actually come out and see it. I think it's a lot easier to do a tour and have a walkthrough.
Cool. I'm renovating a house. I really want to see how that positive pressure works so that all the dust leaves the house instead of coming in. We had a chat the other day and I found out about your European background, and we all know Europe's more advanced in adoption of greener fleet technology. Your collaboration with Forsee, I imagine, will be instructive. Can you talk about the European mindset on green transport and what we can learn from there?
Yeah, absolutely. Look, I think when it comes to promoting green transport, certainly the government or policy has a big role to play, right? I mean, they're often a big customer, and also they can make things happen either through subsidies or disincentives, and we can see that in Europe. Definitely, there's some countries that have put forward bans on internal combustion engines and whatnot, and some as early as 2030. There's also targets around battery recycling and recycled content going into new batteries. They are talking about a group of regulations often referred to as a battery passport, which is very much in the circular economy space, which gives you full traceability of where everything comes from, even right back down to the original mining of materials and the footprint and everything associated with that. Now, elements of that will, I guess, at some point find their way to our shores as well, right? For us, I guess there's two sides to it, right? So I think one thing to note is that whilst we love our electric vehicles, and I love going nice and zippy on the freeway myself, there are means to an end, and they're fit for purpose in some instances and not others, right? So we don't want to get caught up in a debate that, electric vehicles or electrification is the be all and end all, and it'll make everything great, right? There are applications where they're useful, but there are also applications where other powertrains are useful, and certainly if you're traveling long distances, such as in Australia. So that's not a sort of a debate that we talk about. What we do believe shouldn't be up for debate is the fact that we do have a large footprint as a transport sector. And I think if you look at it from a government point of view, so I do close the loop back to the policy thing eventually. Utilities and such are the largest emitting sector in Australia right now. There's a lot of effort around closing of coal-fired power plants and all that sort of stuff. You can imagine that once that's resolved, then transport is the next highest emitting sector. So attention will be paid to this. And so some of the things that we see happening in Europe will in some way, shape or form land on our shores. And I guess we've got the benefit, we can see what's happening there to prepare ourselves so that we're ready. And for us as Infinitev, we're keen on leading the charge and actually starting work on a lot of those sustainable approaches and green transport approaches before the government says, this is what it is and here's how you do it.
Just a sort of more personal question. I was just wondering about your own journey and how working in this space to eliminate waste and save resources fits with your personal values.
Yeah, great question. It's interesting. There's a lot. I talk to the team a lot about you can't be one person at home and another person at work, right? You're one whole person and you got to bring that in. And I guess I've got the privilege of running the business, so a lot of my personal values are also reflected in what we do. And sustainability matters. It's one of the things that we talk about a lot as a business. And there's a silly example that I give, right? If we have a choice between buying recycled paper or non-recycled paper, we buy the recycled paper, right? Even if it costs a little bit more, but for us, that's the right choice. And so for me, I personally really enjoy working on, I guess, the cutting edge of technology and engineering, and some of these battery systems certainly are in that field, but I also like working on things that are meaningful and make things better, not worse, right? And I find I've got a perfect interplay here where those two come together. So yeah, I mean, for me, it's I love that puzzle as well, because it's not obvious. There's a compromise between technological advancement and doing the right thing, and it's not always obvious where the answers lie. And so we dedicate a lot of time on making that happen and helping others to see that this approach that we're proposing isn't just good for the environment, it actually makes sense for a business perspective as well.
Yeah, lovely. I guess just one last question is, how do you at Infinitev go about getting the message out to Australian and New Zealand fleets about what you can do for them and what they can do to become part of the circular economy?
Yeah, I guess one soapbox at a time, I suppose, right? So we do engage quite widely with various peak bodies, industry bodies. I guess we almost have an open door policy, so anybody's always welcome to come and have a chat, see what we do, how we do it. I think sometimes that really helps in sparking the imagination of people seeing what's going on. Look, I think we also need to acknowledge that certainly electrification and therefore high voltage batteries, it's still relatively early days for a lot of companies and fleets out there. And often the first challenge is, okay, well, now I've got this different thing in my fleet. Okay, well, how do I charge it? If I'm running a bus, what does it mean for my scheduling, right? Because this thing charges for a longer time than it takes to fill it up with a diesel, right? So there's a lot of these sort of practical challenges. And then that consideration of, well, what happens to, how do I maintain that battery? Or if something goes wrong with it, how do I repair it? All that sort of stuff tends to come at a later stage. So we do spend a lot of time, I guess, talking to people, just explaining to them what we do, but we're well aware that for some people this is not a today problem, it's a tomorrow problem. And so I guess we have to be a little bit patient. But we do think by having these conversations early on, we can start showing people that it's something that they should be thinking about. And that if they start putting the right groundwork, frameworks in place for their businesses today, that that it'll help them manage this well into the future. They don't have to, they're not left scrambling to go, okay, oh, I've got this battery, it's got a problem, what do I do? You've already done your homework, you know exactly what's going to happen. So yeah, takes a bit of time, but yeah, it's growing, which is fun for us.
Fantastic conversation. I love talking about all of that, the circular economy with you. So thanks for your time today, Bart. And as this is our last episode for 2024, I'd just like to wish you and everyone a safe and happy Christmas.
Awesome. Thanks, Caroline. And same to you. Thanks for having me.
You've been listening to Fleet Auto News podcast. It was edited and produced by Isabella Fiorentino. The original theme music for this podcast was created by Isabella Fiorentino. You can follow us on Spotify. Just search for Fleet Auto News. We're also on Instagram, Facebook and YouTube. Our website is fleetautonews.com, where you can get all our stories, videos and podcasts. Until next time, drive safely and take care.